Ethereum 2.0 Serenity upgrade is just around the corner. A massive undertaking where Ethereum running on proof of work algorithm is going to change and upgrade to proof of stake. Now I've got some very exciting news I want to share with you, and it's about the least authority audit report. Very exciting, and yeah, I'm sure you will enjoy it. My name is Kierin, really happy to have you here with me today. I create cryptocurrency and decentralized finance videos to make sure that you are ready for the next bull run. So hit that subscribe button, join me on the journey. And a very small secret, if you hit that like button, then you get 10x kids. All right, so let's jump right into this. So as you may know, Ethereum is undergoing a very massive upgrade. I mean, it's an upgrade that we haven't seen before in the cryptocurrency space. I mean, there's a lot of moving parts and many things can go wrong, and that's why audit is crucial to make sure that the problems are ironed out, suggestions are made for maybe possible attack vectors and so on. So a quick recap about what's exactly happening with the different upgrade stages. The Ethereum 2.0 Serenity upgrade will happen in 3 different stages. So the first one, which is hopefully this summer, is the phase 0 beacon chain upgrade. This will allow ETH2 staking. I'm sure many of you are excited about that. Then afterwards comes the phase 1 shard chains, which will hopefully improve the scalability of the whole network. And last but not least is the phase 2, the execution environments, where transactions will be also possible. And this is one of the first proof of stake sharded protocol projects planned for production. And that's why it's a very big undertaking. Super complicated things, and in this video I want to try and break the problems down. I won't go through all of them. I'll highlight the main issues that were found to see if they were resolved or not, and then I'll go through 2 main problems, main issues, possible attack vectors, and break them down, make them super simple for you to understand. So grab a beer, grab a coffee, sit down, relax, and I'm sure you're gonna enjoy this video. So the main issues that were found, I won't go through the whole report. If you want to find it, it's on leastauthority.com. I'll link it down below if you want to read the whole report. So I've got the PDF open and I want to look at the specific issues, and that's what we'll be covering. And the broad overview is the following. So the issue A, beacon block propagation restrictions are too loose, so the parameters are not set as high as they should, and this status has been resolved, which is fantastic. Issue B, attestor and proposer slashing message propagation attack has been resolved. Issue C, distributed denial of service DDoS attacks against block proposer. That would mean when many people with their computers would create a request like this, say, hey website pop up, hey website pop up, and refresh the website. In this case, it's a block proposer many times, and that will cause the website to crash or the block proposer to crash. This unfortunately is still not resolved. I hope they've got a solution that they suggested to the Ethereum team. Then we've got the block proposer eclipse attack, the misaligned gossip incentives. We'll be covering some gossip problems later on in the video. Very interesting. I'm sure you'll find it exciting. Now, issue F, bias in the weighted random sampling in election of block proposer, invalid issue. So this is just off the table. It doesn't affect, there's no attack vectors for that. Issue G, gossip hub control message denial of service. This is also about the gossip protocol. And then there's 3 suggestions which are still not resolved. The suggestions, but they're still under research. So I want to dive right into a few of these attack vectors. Now, during an audit, they're going to check the code. They're going to check for logical fallacies, make sure that everything is working as it should, and maybe try and think of some possible attack vectors. So many of the things are based on theory, and a few things that can test, a few things that can't test. And the first one that I want to address is the block proposer system. And to understand how this attack vector can work, I think it's also important that you understand the difference between proof of work and proof of stake, especially concerning which node is selected. So in a proof of work consensus mechanism, the consensus mechanism verifies which node should propose the block. So it's all in the algorithm. The algorithm chooses which node chooses the next block. And in a proof of stake system, like the upcoming Ethereum 2.0, well, basically here you have a block proposer that chooses what goes into the next block. And this is random. This would allow the block proposer to choose what kind of information, what kind of transactions and so on goes into the next block. And this is an information leakage. That means information that would not be available in the proof of work system. And that's something you have to think about, because with information leakage, that can give someone else the possibility to open an attack channel. And yeah, since this information is not available in a proof of work puzzle, in a proof of work algorithm, you have to find a way to prevent this information leakage happening. And the problem is, if someone can find out which node will be the block proposer, he can follow through with an attack. This is theoretical. Now, the suggestion that is proposed by least authority is a single secret leader election. That basically would mean that this will keep the selection of the block proposer a secret. This is just a suggestion. They're still in the research phase. There's nothing being implemented right now. But I think what's good is that the Ethereum team are now aware. They might have been aware before, but now it's documented that they're aware that this is a possible risk. And hopefully they'll use the suggestion that least authority gave them, or they'll come up with their own implementation to eliminate this information leakage, and also make the block proposer selection more random and prevent this information from going to maybe a malicious attacker. Now, the next possible vector of attack would be peer-to-peer networking. And with all decentralized systems, it's very important that most of the nodes in that system are honest. I mean, I'm sure you've heard of a 51% attack. So if a majority of the nodes are dishonest, that could mean that they choose to add their own code to the system, and it can overthrow the whole system. And that just is the worst case scenario of a decentralized system. Now, in a decentralized system, it's also super important that nodes communicate with each other. They have to get information. So for example, one node might say, hi, I'm a node, please give me some transaction information. And he wants that from another node. So he's going to send that information around different nodes so that until he gets what he needs. Another node might say, I want some transaction information. I want to sync the blockchain. Whatever you can imagine, they need to communicate with each other. And for that, there's a protocol in place. And funny enough, it's called gossip protocol, like many grandmas talking together, like chatting, jibber-jabbing and so on. And they're giving information to each other. In the same way, the nodes are communicating with each other. And that's actually a very good thing. However, the main problem with gossip protocols is they suffer from spam. And since there's no central authority in the system, it's very difficult for a script or the protocol to find out which messages are bad and which messages are good. So basically, many messages could be sent, and it's just malicious messages, bad messages, in order to clog the network. So there are some things and safeguards put in place to prevent malicious gossiping, and if a node starts gossiping maliciously, other nodes will send out penalizing messages to make sure that this node gets punished. I think they're actually called slashing messages. And the problem that Least Authority found out is with a very interesting loophole, and that is when nodes start sending out old messages and they spam these old messages, they don't receive a high enough punishment. And this is very interesting, that this is actually happening with old messages, and they should actually get a slashing message from any other nodes, but this is not happening. So they not get punished, and that is something that is really not good and shouldn't happen. And Least Authority suggested a very interesting upgrade. I'm not too familiar with what bar resilient protocol is, but I'm sure you can find that out. However, in a nutshell, what it should do is it should be able to determine which messages are legitimate and which messages that nodes send to each other are spam messages. And this would prevent a malicious node from spamming and clogging up the network. Because if a node manages to clog up the network, then legitimate transactions can just not go through, and that's really bad. So I'll link the report, I'll link the website down below so you can go through it in peace, read through the itty bitty bits, and familiarize yourself with the possible attack vectors. But all in all, I've got a very good feeling about the upgrade. And yeah, I've worked with auditors, and they're very rigorous. They look through all the detail, this very small fine print and everything, and make sure that everything is working, that everything has a head and toe, as you might say. But yeah, so I've got a very good feeling about the upgrade, and I'm looking forward to the phase 0 Beacon chain, looking forward to being able to stake on the Ethereum 2.0 network. So hope you enjoyed this video. I hope you understood what the attack vectors were that I explained to you, the peer-to-peer networking problem and the block proposer system. And yeah, I hope you found it interesting. If you've got any suggestions, leave them in the comments down below. Wish you a fantastic day. I've got some very exciting Ethereum updates coming your way, so make sure you hit that subscribe button to stay up to date. So yeah, wish you a fantastic start into the week, and see you in the next one. Bye bye.